Cool, cool. I'm Dave Rat, and let's talk phantom power. Phantom power is really an interesting and cool tool to use. It's a voltage that we can send down mic lines to power up various things like DI boxes and condenser microphones. I've seen it used for other things. You can use, when I designed the Sound Tools XLR sniffer senders, I designed it around a phantom power type circuit. You can actually use phantom power to test mic lines. The sender unit actually creates 12 volt phantom power that can be used to power 12 volt phantom mics. Typically phantom power is 48 volts, or at least when it first came out. But there are phantom power units that are 9 to 12 volts, there's 24 volt and 48 volt. So there are some lower voltage phantom power sources. Typically a 48 phantom power source will power anything. But due to like battery operated portable units or whatever, a lot of times it's difficult to create 48 volts, or it used to be. So they made various phantom power devices that will run on lower voltages. I remember first buying AKG C451s, and there was a 12 to 48, a phantom power or 48 only version. All right, so phantom power has some mysteries and misconceptions as well. And also there's some interesting stuff about phantom power that even those of you that are well versed in how it works and what it does, that you might find interesting. Phantom power is 48 volts. 48 volts is fairly high. I mean, it's almost half the voltage of 120 wall voltage. That would shock somebody. Conversely, it's very low current. So it's more like getting a shock from rubbing your feet on the carpet, or a balloon, the electrostatic. It's got very low current, so it won't hurt you, but it can be felt, and some people are more sensitive to it than others. And miswired snaking systems, or there can be situations where if something's wired improperly and you get that 48 volts to your lip, you'll definitely taste it and feel an electric shock there. I've been called in on 2 different occasions to resolve people getting shocked. I got a call to the Roxy once, and went down there and found some flaws in the snaking system. But that's all beside the point. Let's go ahead and look at phantom power here. So I've got a little setup. I got a little GoPro up here that's running. Hopefully you can see a good amount of what's going on. I've got 2 mixing boards, both capable of creating phantom power, and then they're tied together through this Sound Tools cap box, which has got an out to this mixing board, out to this mixing board, and then an input, which would be like a mic going to both consoles. So let's first of all start with looking at phantom power. So I'm going to unplug one of the consoles, let that dangle down there, and I'm going to turn on the meter. And I've created an XLR to banana plug to go right into the meter. And let's go ahead and turn this on, and we should see the phantom power show up there. And there it is. It should be approximately 48 volts. 47.4 is good enough. And it doesn't. The thing about phantom power, it doesn't need to be exactly 48 volts. It's basically, it puts out 48 volts, but the various units will drag it down lower, and they're meant to operate on much lower voltage. So it's a high voltage, low current, and it drags down. And the way this cable is wired is, there's the ground is here, this black one, and this blue wire, which you may or may not be able to see, is on pin 2, and this red wire is on pin 3. And if you look, we have 48 volts between the ground and pin 3, for 47.7. We have 47.7 volts between ground and pin 2. And if we look at between pin 2 and pin 3, we see no volts at all. And that's really important. And let's go ahead and look at some pictures here that I drew with my high quality artistic skills. The way phantom power is outputted is the console input, which it's going backwards, right? The console input, your microphone input to the console, phantom power is sent out of that in reverse. So it's going the wrong way down the mic cable. There's no real direction, but it's being sent back to the mic, the opposite direction that the mic signal comes. And pin 1 is ground and there's no voltage on it, or it's the reference of 0 volts. Pin 2 and pin 3 both have 48 volts on it. So we saw that. We saw 48 volts between pin 1 and pin 2, and we saw 48 between pin 1 and pin 3. But if we measure between pin 2 and pin 3, they're both at 48 volts. There's no difference between them, so we don't measure any voltage differential. So there's no voltage offset. All right, so then that would then go down your mic cable here and show up at your microphone. So at the microphone, pin 1 has 0, pin 2 and 3 both have 48 volts, as I just showed on the meter there. Let's go to the next one. Inside of a condenser mic, we have the ground or the reference for all the circuitry inside, and then it takes it and it splits this out into two different directions. One, it grabs the 48 volts from pin 2 and pin 3 through usually a pair of resistors that are equal in value and connects them together and uses that as a 48 volt source that can then be utilized to power various circuitry inside the mic, the little preamp that, and any other filters and stuff, and EQ, or whatever else is going on in that mic that's using the phantom power as the voltage source or as the current source. Additionally, there is the output of the microphone, the signal, and you have the in polarity signal, which shows up on pin 2 on a properly wired mic. You have the out of polarity signal that shows up on pin 3. And there will be a capacitor or something that blocks the 48 volts from going this way. And so this circuitry here is powered by the 48 in the ground and then outputs the signal back down and sends that back down the other way. One of the beauties of electricity is you can run voltages in differing directions, especially if DC and AC. So you could have an AC signal on a pair of wires and a DC voltage on those wires, and you can separate them out and you can combine them together and utilize those independently. And that's what phantom power does. All right, so that's kind of a simplistic version of what we're doing with what the condenser mic is doing. Grabbing the phantom power off those pin 2 and 3 in relation to ground and sending the signal down 2 and 3 back to the mixing board. The mixing board, conversely, it creates a phantom power, it puts the phantom power on, and it does a separation as well. So when the signal comes in, it is pulled off and goes through some capacitors that prevent the phantom power to get to the circuitry, and it's amplified and done up. And there's a special circuit that injects the phantom power onto those lines. All right, so let's go ahead and look at what happens. Now, what happens if we plug in? So let's go ahead and we looked at a condenser mic, so let's plug in a condenser mic. So what we'll do is plug in this Sennheiser KSM 105, and I'm going to plug that into there. Now it's plugged into a Y cable. I'm going to leave this Y cable on there, but basically it's just coming in here. These are just dead ends right now, so we don't really need to worry about it. And we'll plug that in. Oh, we are going to worry about that. So what we're going to do is we're going to plug that onto here, and we're going to look at the phantom power. This right here is, there we go, there's our 48 volts. Okay, that 47 volts, that's slowly rising. Again, not a big deal. So now what we're doing is the phantom power showing up here, it's going into these adapters, and it's only going to the meter. Now watch what happens when I plug the microphone in. I plug the microphone in, it should load this down slightly. See, now the current draw of the microphone has dropped the phantom down to 35 volts. Not a big deal. These mics are designed to that. Phantom power has specifications. If it's designed properly, 35, it can run in 48 volts, the starting point, and it can drop lower than that depending on mic cable lengths. The mic is designed to be able to utilize a wide range of voltage in there. But we do see a drop in voltage when the mic is put on, and we can listen to it, 222, hey, 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 and the mic works. All right. Let's see, what can we do? Let's talk about dynamic mics now. So now, I unplug, we got our 48 volts back. If I take a dynamic mic, we've got 48 volts. What happens when you plug a dynamic mic into this 48 volts? It doesn't need it. Will it hurt it? Well, the way a dynamic mic is basically set up, whether it has a transformer or it's the coil of wire, is very similar. The console puts out 48 volts on pin 3 and pin 2 in relation to ground, or pin 1. And inside the dynamic mic is between pin 2 and 3, and the most simple of mics, like an OM7 that has no transformer, it goes to a coil of wire, which is the voice coil of the attached to the diaphragm, submerged in a magnetic field, and that's it. And then when the sound moves that diaphragm, that voice coil moves back and forth in the magnetic field, and the magic of electricity is if you move a coil of wire immersed in a magnetic field, it will generate electricity. And so this will generate electricity, and it will show up on pin 2 and 3 as, and they will be equal and opposites of each other. So it's just really simple. If it's a mic with a transformer in it, it'll operate almost exactly the same. There'll be a coil of wire that then goes to a transformer, which is a coil of wire near another coil of wire. And then that coil of wire will be connected across pin 2 and 3. And there might be some other stuff in there, but pretty much that's the whole rundown. Now, will 48 hurt this? Well, a minute ago, we measured that we had 48 between pin 2 and pin 1 and 48 between pin 3 and pin 1, and we had 0 volts between pin 2 and pin 3. Well, if there's 0 volts between pin 2 and pin 3, then there's no voltage being put across this coil, and that's okay. That's great. If we were to use an unbalanced cable to power a dynamic mic with phantom power on that unbalanced cable and shorted pin 1 to pin 2, now we would be putting 48 volts across this coil. There's not a lot of current there, but that would not be good for the microphone, for the dynamic mic. And you can actually hear that. If you plug a dynamic mic into phantom power and the cable has a short in it, or it's an unbalanced cable, you'll actually hear the diaphragm pop. And actually, we could do that. I don't mind putting a pop through some of these mics. I got enough of them. So let's go ahead and first of all, what we'll do is we'll plug a dynamic mic. We'll look at the meter. We'll see if it does anything. The meter doesn't change at all. It doesn't drop at all. And I'll listen to the mic. And there's no pop. Let's see. What would be the easiest way to do a pop? Probably to short something out. I'll have to. Okay, so now what we're going to do is let's see what happens when we have a improperly wired cable. So I'm going to use these meter probes to create a pin to hot, an unbalanced cable. And listen for this. I'll get up close so you can hear it. That sound is actually the diaphragm of the mic acting like a speaker and going bam and slamming against the magnet there. You can see that it clips the microphone. All right, I don't recommend doing that to microphones, and as it can damage them, especially delicate mics like a Sennheiser 441 with a really delicate coil, or ribbon mics, it can destroy them. It'll blow that ribbon into pieces. So it's not generally a good idea to put phantom power onto dynamic mics, but phantom powered is designed such that a properly wired system It's in good condition with nothing wrong with it. There is no negative effect directly from phantom power. Again, having phantom power on a dynamic mic, if the cable is slightly crackly, you'll hear that voltage. It can cause issues. So I don't recommend it, but it won't, if everything's working right, it won't hurt the mic. All right, so enough on powering dynamic mics with phantom power. Let's go on to take a look at a more complex setup. Here we have a house console generating phantom power, a monitor console also generating phantom power, and a stage box. The question is, if I turn phantom power on in this console and phantom power on in this console, what's going to happen here? So we've checked phantom power. Let's go ahead and look at that. We will look at the phantom power here on the meter. And there we have 48 volts. I'm going to get my condenser mic back before we put the condenser mic up. Now what I'm going to do is I'm going to turn phantom power off on this console. I'm going to plug in this console. Oh, that one's not muted. I'm going to plug in that console, and I'm going to turn phantom power on. Let's see, unplug that one and turn phantom power on here. And there we have it. So now we're powered phantom power off of this console. Okay, so this is our front of house console, and now we're going to decide, are we going to power off the monitor console or the house console? Well, before we even decide that, let's take a look at what happens when I plug the monitor console in. We're powering off the front of house console now at 46.6 volts. A little variation, no biggie. But now what happens when I plug the monitor console in? The phantom power from the front of house console is being loaded down by the monitor console. The monitor console is actually impacting the phantom power source there. Again, it's not that big of a deal. We're at 38 volts, but optimally we'd have something closer to 48. Depending on the power draw of the mic, we've already lost some energy just by plugging in the monitor console, but the phantom power is not on the monitor console. And now the big question is, what happens if we turn the phantom power on both consoles at the same time? Will 48 plus 48 equal 96? Or will 48 plus 48 equal 48? Well, for this test, let's go ahead and pull out a Neumann U89, because if we're going to do something, test, let's use something expensive to do it with. And we'll plug that in. Let's plug it in hot, and bada boom. Now here we saw the phantom power drop from 35 down, and then it's come back up again to close to where it was before, even a little higher, which is interesting. Okay, so now we've got the mic. Let's go ahead and test that. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Yep. And we have power mission control. All right. What happens if we turn phantom power on both consoles? It's climbing. And boom, we got 46 volts. And let's see what it sounds like. 2, 2, 2, 2, 2, 2, 2, 2, and we are all good. What happens if we unplug the mic with the two phantom powers? What happens? We go to 48 volts. So with both consoles on, I'll turn one off. I'll turn the other one off. I'll turn the first one on. And I'll turn the other one on. 48 volts from two different sources gives us 48 volts because those sources are in parallel with each other. And when two voltage sources are in parallel, the voltage stays the same, but the current increases. And the current has allowed us to supply a more stable voltage to the microphone. Here's an example of that with two 9-volt batteries. If you connect the pluses together and the minuses together, the output will still be 9 volts. And this is something you can test at home with a meter. If you want to, the whole concept that the voltage will double and it'll hurt microphones is based on the wiring of series wiring, where you would take the plus of one battery and hook it to the minus of the other. So you'd have 0 volts in the minus, the plus would be 9 volts, and you'd send 9 volts to the minus of the other one, and they would add another 9 and end up with 18. So it would be possible to create a 96 volts, a 96 volt source with this by hooking them up in series, assuming that they're isolated enough. But that's not what's happening. Okay, so that's pretty much it. The general, the overall view is that there's really no good reason not to use phantom power from both microphones, from both consoles, stabilize that voltage source. Keep in mind that phantom power does not pass through isolation transformers. So if you do have isolation transformers and an ISO split, you're going to want a phantom from whatever console is hardwired to the mics and not the one that's on the other side of the transformers. Now, the phantom will not hurt transformers. Again, they're designed in such a way, just like the inside of a dynamic mic, so that when you have 48 volts on both sides of that coil of wire, there's 0 volts drop across the coil, and it won't have any damage to the transformer. It won't cause any audio quality loss. It won't hurt anything. All right, well, that should just about do it. I thought it was pretty interesting. I knew the outcome of the 48 volts in parallel, and I've been doing powering from multiple sources whenever possible. What I was surprised to see is I had not measured this before and saw that one console was loading down the phantom power of the other console. That would increase as well. If you had 3 consoles, or if you've got 2 consoles and then you're splitting into a record feed and maybe there's a transformer there, the transformer won't put a load, but if it's not a transformer into the record feed, you have another direct input, those will continue to load down that phantom. All right, well, hopefully this is interesting and helpful, and cool. I'll do another video soon.